this video I'm going to show how the Cyk algorithm works for the code I made in Python, and because the restriction and the size of the string that I test must be size 4. So here we have our code, and we're going to run the program. The example that we are going to use for this code is going to be this one. Here we have 3 terminals, 2 variables, and 5 rules. So we run the code, 2 variables, 3 terminals, and 5 rules. So we set the first 2 variables, the 2 terminals that are A, B, S, and our initial terminal S. For our rules that we're going to use, it asks us which terminal is assigned to the rule. So we have S led us to AB, A led us to ABB, and A led us to lowercase a, and B led us to lowercase b, and also B led us to uppercase AB. So here we have our 5 words, 1, 2, 3, 5. And our string that we're going to be testing is going to be BBAB. So we write BB, lowercase, AB, and we run it. It is accepted, and I'm going to show you how this is calculated. So for the first line 1 calculations, we have here that it is an iteration of each character from the string, and it uses this first finding available rules. That what this code does is from the terminal we send the terminal that matches with the rule and the variable. So here we send the variable, and from each rule we find the rule that matches this variable from the string, and here we return the terminal in this list as a list, and that's it. We append it and we print it. So for the length 2, we have to divide our string into the first 2, the second 2, and the last 2. So for this example, we find the first 2 available rules. We send to our function second finding of the available rule the string, the letter first and the second letter. We iterate it and we subtract 1 to not surpass the index. And here we append the rules to this append. What it does, it writes BB to find the corresponding key, and here from the second rule we make a join with the first and the second part of this rule, and we append it to this one when we find the available rules. What this does is give us A and B, BB, so we're going to get B from this one, the terminal B, and also another B. And from this, the finding of the rules, what it does is it finds the rules that matches the uppercase BB, so it's going to be A, and we get that this is A, and we see that it matches our results, A0 and S and B, A0 and S and B. So we append it and we save it in a variable that second rules. So in this case we have the first rules and the second rules saved that we're going to use later in our code. So for the length 3, we initialize this list in order to be empty when we want to write data too. So here we append this one that also appends this to know the key of the rule. And what we do here is we separate the second and the third character from the string, and we find the coincidence rules that give us this one. So we look in this list which matches this, and we get it, second rules. And we do the join with the first coincidence that we can send here. The first letter is going to be like this one. Here we append the first and the second letter, first and second letter, and the last letter. This is going to be this one, and we append it here. We made the manual join from the coincidences, and we find the rules that match this, and it's going to be AA. So the join gives us AA. Here is the join, and it is nothing. And as we can see from the second part, we do this the same, first and second letter. First and second letter, it is switched, but it's first and second letter and the last letter. And we also do the join. From this we get here, and it is according to the first rules. Here is the join that it's going to give us B and nothing. And as you can see, here we find the rules for it's going to be only B, but there's no rule that leads us to only B, so it is nothing. And that's it. The same for the second part. And for the length 4, we get X and B. So for length we get these three. We have to separate our string into the length. So first we separate it with B, the first character, the 3, 2 and 2, and 3 and 1. So here we have the 3 separation, and we look it with the third rules that we got from the previous length, and we send it 1, 2, 3 character, and the first it is stayed here. So from this we get BA, and from BA there is no rule that gives us to BA, I didn't write, but this is empty. And here from the second coincidence we divide it into 2 and 2, we get 0 and 1, 2 and 3. And we make the join with the coincidence. This looks for the second rules, and we find available rules for this. In this case, it is S and B, and it's what we got here. And for the third one, we separate into 3 and 1. Here we have the 1, 2, 3, and we find here the coincidence that it gives us nothing. And we find the coincidence with this one and the last one that gives us B. So there are no rules that lead us only to B, so it returns nothing, and as we can see, it only got this one from the second finding. So that's how we find the rules, and then we make a join from this list and this list. There is a union that it unifies the first and the second list, and it puts the characters that are not the same in the both lists. And from this union we make it to the third, and it's the same. It doesn't have to repeat the characters that are in there. We print it and we got this union. And for the accepted, you use this as a function that we find if the terms have length 1, but we are going to only compare it once. So if it is equal, it is also returning, and that's it. But if we have more elements, like in this case, we iterate until we find the matching the machine character with the initial terminal. And that's it. That's how this works. And as we can see, we get the same results from doing it by hand. Then with the code, here we have this, and it's the same as getting it with hand. Here we have the four results: BBA nothing SMB, BA nothing SMB, and BBA leads to nothing, and BAB. BA that give us nothing, and A. So for the length form, we have BBAB that leads us to S and B. So it goes S and B. So this is accepted, but we have this initial in our final string. So that's it, and that's how this code works. Thanks.